so we're going to call these mole ratios. Mole ratio. This is the step where we're going to start thinking about how compounds are related to other compounds. Oh boy. And we usually, like, it's somewhat abstract. Our reactions are back. So we've done some with types of reactions. We did some with balancing reactions. We know all the stuff you start with is all called reactants. You do the reaction, that arrow is like doing the reaction, and you form the products. The mole ratio describes how much you can form based on what you start with, or if you want a certain thing, how much you have to start with in order to form that much. We'll take, we're going to do an example here just to like clarify this a little bit, because part one I just said this was easy, and now there's like a reaction involved also. Oh boy. Okay, so let's take an example reaction, and we'll do more examples in the example video also. Oops. So here's just a reaction, an example reaction. Here's the mole ratio. We would say 3 moles of H2, and we can even write this one. So 3 moles of H2 plus 1 mole of N2 forms 2 moles of NH3. So if I start with 3 moles of H2, here I'll just do this too. There's that word, there's that word, and there I just wrote out, You could do this another way too. You could say 3 molecules of H2 plus 1 molecule of N2 forms 2 molecules of NH3. You could even, let's say you start with 100 molecule, no, try again. Let's make that a somewhat nicer number. Let's say you start with 300 molecules of H2. How many molecules of N2 would 300 molecules of H2 react with? This is your ratio part. Every 3 molecules of H2 needs 1 molecule of N2. So if you've got 300 molecules of H2, you're going to want 100 molecules of N2. And if you've got that, if you've got 300 molecules of H2, 100 molecules of N2, how many molecules of NH3 can you form? We just scaled this picture up by 100 and just multiply that whole deal by 100. Same thing with your product. So 3 molecules of H2 plus 1 molecule of N2 forms 2 molecules of NH3. Scale it up by 100. 300 molecules of H2, 100 molecules of N2, 200 molecules NH3. Maybe I should have done that first. Because now I bet that mole thing makes even more sense. Because a mole is just a number. It's just like a really big 100. And it works the same way. Like, it's kind of easier to count in moles. Because, like, moles, like 3 moles is a pretty typical amount. 3 moles of H2. And you're starting to see it. And we've got it up there too. 1 mole of N2 forms 2 moles NH3. The other kind of moment that you have somewhere in here is seeing how these numbers, these ratio numbers, relate to the coefficients in your original reaction. So back in the Dark Ages, we figured out how to balance things. I could have given you this as a skeleton. You could have balanced this all by yourself. You know how to balance reactions. But I'm not sure if you ever exactly entirely knew why you were balancing reactions, except that you were supposed to, and they were like a logic puzzle, and great. Like, yes, you are balancing reactions, perfect. This is why. And you can draw a picture too if you want. Once a reaction is balanced, those coefficients tell you the ratio of the compounds involved. So if we were to draw a picture, here's 3 molecules of H2. Here's 1 molecule of N2 forms 2 molecules of NH3. And if you want, you can count your atoms. Your 3 molecules of H2 had 6 H atoms. Your 2 molecules of NH3 have 6 atoms of H atoms. Your N2, your 2 nitrogen atoms just like split apart from each other there. So the coefficients of the balanced reaction are the mole ratios. Coefficients of the balanced reaction are the mole ratios. So if we take this one, oh, yeah, great, this is perfect. We'll do this here, and then we'll do one on the example page, and that'll be a super fast video. But take that same reaction, and if we wanted to know the ratio of H2 to NH3, we're just looking for those coefficients. There's your H2. You need 3 moles of H2, and that'll form your ratio. Find your NH3, find the coefficient in front of the NH3. It'll form 2 moles of NH3. Or what if we wanted the ratio of N2 to H2? Find your coefficients. There's your N2, 1 mole of N2 reacts with, find your coefficient, 3 moles of H2. I'm going to do your last example right here, and then you don't even have to click another video, because this is it. It's not going to get much more. I'll show you number 2 below also, and that's like, that's as complicated as this gets. Do the same thing. This is even the same reaction, by the way, which was not planned, even though it kind of looks planned, but whatever. Here you're looking for your ratio. These are all mole ratios. N2, so 1 mole of N2 reacts with 3 moles of H2. Done. NH3 has coefficient of 2. 2 moles of NH3 forms from H2. There's your H2, 3 moles of H2. Feel free to just fly through these. Think about the moles, along the way, how many moles it takes to react with or form. This is done. So I'd show you oh no, I'll show you the practice thing down here. I don't need to show you anything. They already have it for you. We'll go to number 1. How many moles of H2O? They filled in some of this for you. Equal sign moles of H2O are produced when 5 moles of oxygen are used. 5 moles of oxygen, that's where you're going to start. So there's your 5 moles of oxygen. Everything starts over 1, it is itself. Here's your mole ratio in action in a real equation here. It's another domino conversion. Moles of O2 cancels with moles of O2. You're forming moles of water. Moles of water is the last thing left on top. That new step, what we just did here, is what they've got there for you. Those are the coefficients. How many moles of H2O? 2 moles of H2O form. There's another coefficient from 1 mole of oxygen. 1 mole of oxygen. So if you start with 1 mole of oxygen, you can form 2 moles of water. If you start with 5 moles of O2, you can form 10 moles of water. Great. Try number 2 and number 3. 4 is like serious bonus. As in, like, you do not have to try. Like, you can read 4 and kind of contemplate what you would do with 4. That's just fine. I'll take you through a whole nother set of stuff before you're looking at 4. For real. But try 2 and 3. You've got 2 and 3. And try these. Feel free to fly. Don't overthink these. They are that simple. You're just pulling the coefficients. Mole ratios are the coefficients. Coefficients are the mole ratios. Feel free to ponder this as long as you're kind of wrapping your brain around it, But it's just another way to kind of say the reaction. 3 moles of H2 plus 1 mole of N2 forms 2 moles of NH3. It's just a counting unit. But it's a counting unit with like all sorts of handy applications, because as you saw in the previous video, we use moles all the time. You're just figuring out how to apply what you know about moles now to an actual reaction. And that's all. That's your lesson and your examples all in the same video. Oops, it's fine, you got it. Crunch a whole bunch. There's a review guide for you tomorrow as well. Again, the mole ratio stuff will not be on tomorrow's quiz, but we will use it next week, unsurprisingly. Enjoy!